Alright guys, we're going to look at finding the x and y intercept linearly and exponentially. So most time you're going to see the linear equation in standard form here, xy plus by equals c. What is an intercept of a graph? Is the point where the function crosses the x or y axis. If it crosses the x-axis, that's your x-intercept. Y-axis is y-intercept. What does the x-intercept look like in an ordered pair? Well, you got a number and 0 for your y. Whenever you're finding your x-intercept, your y value is 0. Alright. And same thing for your y. Your x value is 0. And that'll give you your y-intercept. Just like right here. Crosses my x-axis, my x-intercept. Crosses the y value is my y-axis, my y-intercept. Here's just an example of x-intercept. Notice my y value is 0. Steps: find the y-intercept. Substitute 0 for x and solve for y. Write as an ordered pair. Find the x-intercept. Substitute 0 for y. Then solve for x. Write as an ordered pair. Plot the ordered pairs in the coordinate plane. Draw the line through the points. Label each intercept on the graph. Alright, right here on this one. Identify the x and y intercept. Notice right here it crosses at 0, 2, which is my y-intercept, but notice it doesn't cross the x-axis. But notice it is right there on top of 1. It keeps going right on top of 1. And that's what's known as an asymptote. And on that one, the line y equals 0, or excuse me, y equals 1 is the asymptote where it crosses. It's not going to cross that line. So since it doesn't cross the x-axis, there is no x-intercept, which means none. And a lot of times on exponential functions, the x-intercept will be none. We're going to talk in a minute when you will have an x-intercept. The y-intercept we've already taught was 0, 2. And I just went ahead and talked a little bit about exponential equation. Your a here is your y-intercept. Your b here is your rate of change. Alright, and k right here is going to be your asymptote, which will affect how your line moves up and down on your y-axis, and which affects your y-intercept, which is going to affect a, and x here is your x value, which is exponent in exponential, and y is your total or your y value. Now I just made an equation here of this one. We said is y equals 1, so I got f of x equals 2x plus 1. We said that was our k here. Alright, so if I want to find my y-intercept, I want to make my x value 0. Notice I put a 0 for my exponent where my x was. So 2 to 0, anything raised to 0 powers 1. 1 plus 1 is 2. So notice our y-intercept was 0, 2. Alright, and down here at the bottom it's just how you would do it linearly. Plug in 0. For x here to find your y-intercept, you get 0. And then you got negative y equals 6. Divided by negative 1, we get a negative 6. Same thing for your y-intercept here. You make, same thing for your x-intercept. You get rid of your y, divide by 3. Your x-intercept here is going to be 2, 0. Notice I can make me a straight line through there, and I have the slope and everything of that line just using my intercepts. Alright, just work on that practice on the back. Naming your x, y intercept. Now this is an example of when you will have an x-intercept. Now we don't do logarithmic functions in 9th grade, so we're just going to kind of look at the graph in a table and try to figure out where our x-intercept might be. So if I had the function f of x equals 2x minus 5, and I graphed it right here. My asymptote here will be y equals -5. That's where it's never going to cross -5 here. And my y-intercept here, if I was going to find it, again, I'd make x 0 minus 5. 2 to the 0 is 1. 1 minus 5 is -4. Notice it crosses at -4 here. Notice my y-intercept here is 0, -4. And notice my x-intercept crosses in between 2 and 3. So if you look right here, my x-intercept. And I looked at my table, and it was between 2 and 3. And it looks like it was closer to 2, so I just labeled it 2.30. And that's just a guessing it without using logarithmic functions. Alright. So that's it. What about intercepts?